Hello everyone, my name is Mehdi Kordavasi and this is the third movie about the software architecture and design, chapter 3. In this movie, we are talking about the layered architectural style. Let's start. Layered architecture focuses on the grouping of related functionality within an application into distinct layers that are stacked vertically on top of each other. As you see in these pictures, there are three layers. Each layers have a different functionality and the related functional items gather in each uh, separate and individual layer. Functionality within each layer is related by a common rule or responsibility. Communication between layers is explicit and loosely coupled. Layering your application appropriately helps to support a strong separation of concerns that in turn supports flexibility and maintainability. The layers of an application may reside on the same physical computer, it means the same tier, or may be distributed over separated computers or N tiers. And the components in each layer communicate with components in other layers through a well-defined interfaces. For example, a typical web application design consists of the presentation layer, functionality related to the UI or user interface, and a business layer, including the business rules processing, and the data layer, functionality related to the data access framework. The layered architectural style has been described an inverted pyramid of reuse, where each layer aggregates the responsibility and abstractions of the layers directly beneath it. Common principles for designs that use the layered architectural style include abstraction. Layered architecture abstracts the view of the system as a whole, while providing enough detail to understand the rules and responsibility of individual layers and the relationships between them. Another common principle is encapsulation. It means no assumptions need to be made about data types, methods, and properties, or implementation during design, as these features are not exposed at layer boundaries. The next is clearly defined functional layers. The separation between functionality in each layer is clear. Upper layers, such as the presentation layer, send commands to lower layers, such as the business and data layers, and maybe react to events in these layers, allowing data to flow both up and down between the layers. Next principle is high cohesion, well-defined responsibility, boundaries for each layer, and ensuring that each layer contains functionality directly related to the task of that layer will help to maximize cohesion within the layer. Next principle is reusable. Lower layers have no dependency on higher layers, potentially allowing them to be reusable in other scenarios. And the last one is a loose coupling. Communication between layers is based on abstraction and events to provide loose coupling between layers. Let's watch a short 5-minute movie about the layer architecture on the web service.
I would introduce the concept of layering. As we know, it is a very common technique that software designers use to break apart a complicated software system. In layering, each layer is a package of software that has a well-defined interface and a few well-known dependencies with other layers. In that, each layer implements one technical function within the application. For example, a data access layer is responsible for encapsulating the technical means for accessing a database. Now we are having a three-layer architecture of the logical layers. In that we are having different types of layer: presentation layer, service layer, domain layer, infrastructure layer. Each layer is having its own functionality that I am going to explain. First one is the presentation layer. It is also known as the front-end layer, user interface layer. Presentation layer is responsible for creating and displaying the user interface and handling user interaction. The data shown is fetched from the domain layer. Next one is the service layer. Service layer is also known as the web service layer. Service layer is responsible for exposing a web service API and returning a method result as a XML format or the JSON format. Next one is the domain layer. The domain layer is also known as a business layer. It is responsible for all the business logic in the application. The domain layer consists two things: domain model and the domain service. The domain model is also known as the business model, business object, or the business entity. Domain model is responsible for having a model that reflects how a business stakeholder look at the world. It consists of entities with relationship and behavior. Now the domain service is also known as the business service or the business manager. In that, business logic that does not belong within the entity. The next one is the infrastructure layer. It is also known as data access layer, repository layer. It is responsible for querying a database, calling a web service, and sending an email, etc. Now we are having the working of the architecture, which I have explained in the context of a banking system. Suppose a user wants to know which customer is working in the organization or run his own business. The user can get this thing using the layering architecture, using the logical layering architecture. In that, the user firing the query in the XML form at the service layer. Then service layer fetches the customer and the account detail from the domain layer. At that domain layer, we are having two things: domain model and the domain service. The domain model make the result in the compatible form and give the result to the infrastructure layer, and the infrastructure layer in turn make the customer and the account fetcher database command to the database. Then database will give the appropriate result. The results are given to the infrastructure layer, and then infrastructure layer send the given result the result to the domain layer. The domain layer make the customer building service, which then sent to the presentation layer. The customer builder service is generated by the domain service. At the presentation layer, the customer status controller works and give the index view of the result and give the result in the HTML format to the user. Then why should we have many layers? We are having the certain advantages of having the layering system as listed here that are the we are having less code per layer. If we are having a single layer architecture, we have to do a lot of programming, a lot of code. But we have to divide the architecture in a layering form, then we have to do the programming or the coding part for a particular layer. That is very low as compared to the previous one. In that layering concept, we are having the reduced complexity. It is easier to maintain. It is very easier to add new functionality in the layering system. A layering system is easier to test. And that layering system, we are having the concept of reuse code across application. Now we are having the pros and cons of the layering system. We are having the different pros, which are you can understand a single layer as a coherent whole without knowing much about the other layer. As I told earlier, separation of concern among components are there. Components are reusable by multiple applications, as I also listed previously. Independent team able to work on the part of solution. That is a very important advantages of the layering system. Now we are having the crowns. In that layer encapsulates some but not all things well. As the result, you sometimes get cascading changes. That is a very big drawback. And another one is extra layer can harm a performance. Thank you.
Okay, in the next short movie about 3 minutes, and another as example of another multi-layer security for the next generation application, and it helps us to have a better understanding of multi-layer architecturing. Let's see together.
Another video in the series, Choosing the Right Next Generation Firewall. We will be going through multi-layer security and Check Point's Software Blades architecture. Many decades ago, the Bullion Depository at Fort Knox was built to provide the best and most advanced security to protect the United States Gold Reserve. Secured by video cameras, armed guards, massive vault doors, a fortress-like structure, minefields, and highly controlled access, the depository, with its complex layered defenses, is considered nearly impenetrable. So what does this have to do with networks and data? Many companies today deploy complex layered defenses in their networks in order to protect valuable assets, their data. Organizations often lose rather than gain control over their security as they deploy many disparate point products. Check Point enables companies to extend the firewall into a multi-function security gateway that consolidates protection into a single unified solution using its Software Blades architecture. For each layer in the network, individual or multiple software blades provide the security functions. Combined, they deliver the strong multi-layer security required by organizations. At the heart of these security functions is Check Point's context-aware packet processing. It is proven to provide more security at faster speeds than any other type of processing in the market. Let's take a look at how a Check Point security gateway processes and applies security functions. After a connection is accepted by the firewall, the context of a packet is determined before deep analysis is performed. Context-aware packet inspection considers the type of a packet, what, if any, type of command it is, what type of data, enclosures, or files it contains. Once context has been determined, the context manager then applies relevant protections to detect and stop threats based upon predefined policies. Parallel processing enables multiple inspection engines to execute at the same time, as well as simultaneous pattern matching. The benefits of the Check Point's context-aware packet processing are: protections are matched only on relevant data, leading to better performance and fewer false positives. Ability to write very specific protections since they are context-aware. Focused parallel processing increases speed and eliminates unneeded inspection. Packets are inspected once and do not have to be replayed for multiple security inspections. With Check Point's multi-layer security powered by the Software Blade architecture and its leading context-aware packet processing, companies benefit from the most secure and scalable solution available.
Main benefits of layer architectural style. The first is abstraction. Layers allow change to be made at all abstract level. You can increase or decrease the level of abstraction, and you use in each layer of the hierarchical stack. The next is isolation. Allows you to isolate technology upgrades to individual layers in order to reduce risk and minimize impact on the overall system. The next benefit is manageability. Separation of core concerns help to identify dependencies and organize the code into more manageable sections. Manageability is the next one. Okay, the next one is the performance. Distributing the layers over multiple physical tiers can improve scalability, fault tolerance, and performance. The next one is reusability. Roles promote reusability. For example, in MVC, the controller can often be reused with other compatible views in order to provide a role-specific or a user-customized view on the same data and functionality. The next one is the testability. Increased testability arises from having well-defined layer interfaces, as well as the ability to switch between different implementations of the layers interfaces. Separated presentation patterns allows you to build mock objects that mimic the behavior of concrete objects such as model, controller, or view during the test.
A tier in software architecture is a boundary between a layer of the application. So you've got the presentation layer, you can have a business layer, and you can have the data layer. And those are three layers of a three-tier application. Oftentimes the data layer is actually a database, and it has maybe stored procedures that run inside the database, and that's considered its own tier. And so the business objects tier, the center tier, is a backend process that runs on a server that allows your front end to talk to a database. It's considered bad programming practice in modern development to have your front end application talking direct to the database, because that traps you into so many ways, and it also introduces some security vulnerabilities, especially if your front end is running on a client's computer, or it's a website and it's written in JavaScript or HTML. Having a JavaScript programmed right directly to the database would be terrible. So oftentimes you see minimum 3 tiers. There is such a thing as a 4-tier or a 5-tier application. How does that work? So I've worked in companies that split their business tier into 2 separate tiers. What you have is the business layer, and then you have a data access layer. That's written in code. That can be, there are things like Microsoft does have an enterprise library that does come with data access block, but you can write code that simply interfaces with a database. You can call a method, it does one thing, returns the results to the caller, but the business layer contains the business logic. So basically, an N-tier architecture is a software program divided into tiers. The front end, the presentation tier, could be the web development, could be a mobile app, could be running on your desktop, business tier running on a server, and the data tier oftentimes running inside of a database. And that's an N-tier architecture. Thanks for watching. If you have any questions,
Okay, let's watch another 3 minutes short video about interior architectural design.
Video, I'll explain the concept of N-tier architecture and why it's so useful in your business web applications. N-tier architecture means an application is separated into multiple or n number of tiers. While this could refer to any number of tiers, applications are most commonly broken up into 3 different tiers. The presentation layer, which is what the user sees in the browser, the application layer, which holds your business logic, and the data layer, which stores the application's data. While each of these layers work together to make a single application, they also operate independent of one another. In fact, you could place each layer on different computers inside your office and the application would still operate efficiently. So let me quickly explain a few reasons why this is so important. First, this is more secure. N-tier architecture lets you enforce security differently for each tier. For example, the business logic tier and the data tier may require more security than the presentation layer. N-tier architecture gives you full control over security on each layer. Second, it scales well. N-tier architecture lets you scale individual tiers as needed, which means your application will grow with your company. For example, you can scale up your data tier with database clustering without touching the other 2 tiers. Third, it's easier to maintain. Different people can manage single tiers without the risk of touching the other tiers. For example, you would want your web designer working on the presentation layer, but you wouldn't want them touching the business logic or data. And finally, N-tier architecture lets you easily upgrade and modify applications. You can upgrade or enhance each individual layer separately without touching the other layers. For example, you could add additional databases to the data tier if your company expands, or you could add new business rules to their application layer if, for example, your company expands globally and needs different business rules for different countries. Or you could even add multiple presentation layers to each application, which is especially useful for mobile apps. For instance, we create 3 separate presentation layers for each web application. Each presentation layer delivers a different experience depending on the device on which it's accessed. For instance, if a user accesses this application on a smartphone, the application automatically identifies the device and displays the smartphone layer. Likewise, if the user is on a tablet, they will see the tablet layer, and if the user is on a PC, they will see the PC layer. This way, we only create one app, but it looks different on each device. So to recap, N-tier architecture is so important because it breaks the application up into 3 different layers, which can operate independently of one another. This creates applications that are more secure, easily scalable, easily maintained, and easily enhanced. If you'd like to build any
Okay, thank you for watching this movie, and for the next movie we will talk about the message box architectural style. Thank you.